Good morning friends. As of now, we have completed the bending stress part. Okay. Today we will going on the next part, shear stresses on a beam. Okay. In that bending stresses, we are consider only the pure bending, or we can say the simple bending. We are consider there is a no shear stress is induced. But in the practically, if you are applying the some load on any type of the beam, then there is a shear stress are induced. Okay, so we want to calculate that value with the help of shear stress formula. You know the what is the shear stress? We have seen again in the first unit, when two equal and opposite parallel forces acting to the parallel forces acting tangentially to the surface of the body, it is called as a shear stress, and it is denoted by tau. It is denoted by the tau. Okay, I will skip the derivation part and I will explain how to get that formula with the help of any other section. Okay, here is also we will see the different sections: rectangular section, I section, T section, then circular section, etc. Okay, with the help of that you have to calculate the shear stress distribution diagram as well as the value of the shear stress. Okay, then we will see what is the meaning of that formula. Remember that first, tau is equal to, some books you have given the notation yes or yep, don't confuse. Here we use the yes notation for the shear force. Okay, shear force S into A into y bar divided by B into I. Okay, remember this formula, S into A into y bar divided by B into I. What is the S? S is the shear force at the section under the consideration. Okay, under the consideration. Then second, A, what is the area below or above the layer? Okay, in any type of the beam, we will consider one layer. Okay, we will take the small part of that beam. Okay, we are not calculate for the whole part. We will consider only the small part. That's why area below or above that layer. Okay. Suppose we are consider the here CD, we want to consider the area above the layer, that ABCD is the area. Then y bar is the distance of the centroid of area. Okay, from the neutral axis. Remember that. What is the y bar? Y bar is the distance of centroid of area. If you have considered any area in the particular beam, that area you have to calculate the centroid. Okay, and you have to take distance from that centroid to the neutral axis. This is the y bar. Then P is the width of the layer. Okay, you have to consider the triangular, then you will get the different width. If you have considered the rectangular, then you will get the same width. Okay, because see here width of that rectangular is B. If you have considered this CD is the layer, here also you will get the same width. But if you have considered the rectangular, suppose here is a B is there. Okay, then what is the width of that layer? Suppose here is a layer, then what is the width of that layer? This width we want to consider the width of the layer. Okay, each and every section you will get the different width. Remember that. Then we have seen the I is the moment of inertia of that section. If you have given the rectangular section, then circular section, triangular section, what is the value of I? In the last lecture we have seen. Again we will require some bending formula and also shear force. Okay, we have seen the shear force and bending in the second unit. If you have given the different beam or different loading, then you have to calculate again the bending. and shear force. Okay, then I have taken here one example. We want to calculate first shear stress distribution for the rectangular beam. Shear stress distribution, I will write here. Shear stress distribution over the rectangular beam. You will get some idea how to use this formula. Rectangular beam. Okay, shear stress distribution over the rectangular beam. See, I have considered one rectangular beam having the width B and depth D. Also, I have considered the small portion from that rectangular beam, or I have considered here layer is a CD layer. Okay, so you will get this area. I have showing the shaded area A, B, C, D. You want to consider from that rectangular body. Okay, then we want to calculate that force is given. Okay, no need to calculate the force, shear force. Then we want to calculate the area for that rectangular section. You know what is the area for the rectangular section? We will consider here only the shaded area of the shaded portion first. See, if you remember this formula, then easily we can calculate area of shaded portion. Okay, which portion? Shaded portion? ABCD. Area of the shaded portion. Okay, how to calculate that area? We know the area of the rectangular beam. Okay, this B into D is there. But we want to calculate the area for this. What is the width? Here we will get the same width. CD for that layer. We will get the same width is a B is there. How to calculate this value? How to calculate this depth value? This shaded only. Okay. See, this where is the centroid of that body? At the center, because body is symmetric. Right? That's why we get this distance D by 2. D by 2 is there. Okay. Then what we will do? I will consider this distance from the neutral axis to the layer is y. Okay. I will consider the distance from the neutral axis to the layer CD is y. Okay. Then easily you can calculate this distance. What is this distance? This D by 2 minus y. You will get this AC distance or BD distance. Okay. Then what is the area? Area of the shaded portion. The width of the rectangular beam is B and into D by 2 minus y. You will get the area of the shaded portion. Okay. Then second, check that y bar. We want to calculate the y bar. What is the y bar? Y bar is the distance of centroid. Distance of centroid of area. Centroid of area from neutral axis. Where is the neutral axis? Here at the half distance. Okay. Then which distance? What is the meaning of that? Distance of centroid of area. What is the area centroid of this area? Again, here is the rectangular section. Where we will get the centroid of that shaded portion? Half distance, right? Means here. Suppose here, right? And this distance from where? Neutral axis. Where is the neutral axis? Here, at the center. This distance is y bar. Yes, all of you clear? What is the y bar? Y bar is nothing but the distance of centroid of area from the neutral axis. Very simple. This distance we want to calculate. And how to calculate this? We know this distance. We have calculated already. D by 2 minus y. Means we want to take the half of that. Okay. Then I will write y bar is equal to 1 by 2 into D by 2 minus y. Okay. We have calculated this distance, only this one. Right? This distance. Okay, we know that distance D by 2 minus y. Shaded portion distance, what is this distance? d by 2 minus y. If you are doing the half of this distance, then you will get this distance, and this to this we have the y. Okay, up to the neutral axis. Then I will do the plus y. Okay, then you have to solve this equation. I will multiply by inside the bracket. D by 4 minus y by 2 plus y is there. Then if you are solving, then you will get the y bar is equal to 1 by 2. I will take the common. Then d by 2 plus y. 2y minus y. You will get the y value. Okay, this is the y bar distance. Okay, all of you clear how to calculate the y bar? Y bar is nothing but the distance of centroid of area from the neutral axis. न्यूट्रल ॲक्सिस पासून जे डिस्टन्स आहे तुम्ही जे कन्सिडर केलेल्या एरियाच्या सेंट्रॉइडचं, दिस डिस्टन्स इज कॉल्ड एज ए y bar. Next we know the moment of inertia. We will calculate the I. Third is B is equal to B. Width will get the same. Check that. Here is a rectangular portion. This is parallelly or symmetrically. Here also will get the same distance at that layer, at any layer. Okay. That's why you will get the B is equal to B. No need to calculate the B value. Then moment of inertia of section, the moment of inertia of this section is equal to what you will get? Rectangular section we have seen BD cube divided by 12 is there. BD cube divided by 12 is there. Okay. Then you can calculate the shear stress at any layer. Okay. At any layer, we are consider here CD layer. You can calculate any layer. If you consider here layer, then you can calculate below the neutral axis. You will get the same because figure is symmetric. Okay. Then we want to calculate shear stress distribution. Shear stress at any layer, that is CD. That is CD. We know the formula tau is equal to S into A into Y bar divided by B into I. Okay. Then we put the value only in this formula. Tau S into what is the value of area? What is the value of area? I will write here B into D by 2 minus Y is there. Okay. Into Y bar. What is the value of Y bar? Into 1 by 2 d by 2 plus y is there, right? Y is there divided by b into I. B into I. What is the value of b? As it is. Then I, what is the value of I? BD cube divided by 12. You will get this formula. If you have solved this formula, shear stress at any layer, then you will get the tau is equal to, check that this b get cancelled. You will get the 6s BD square, 6s BD cube is there. 6s. If you solve this, then you will get the 6s divided by BD cube, D square divided by 4, D square divided by 4 minus y square. Okay, this is the standard formula of stress induced in the rectangular beam. Okay, this is the shear stress distribution for the rectangular beam. All of you getting how to use this formula for any section? Here you have given the rectangular section. If you have given the circular section, then again similar way you have to calculate the value of A, Y bar, B and I value. Okay, only the formula will change, but procedure is same. Procedure is same. Getting? Yes, good. The next one. See, if you are observing this equation, if you observe this equation as per the observations, check that when the tau is increases as y is decreases. Okay, first see as per the observations, that equations. First observation, tau increases as y decreases. If y decreases, then and then only the tau is increases. Okay, y is 0, then again you will get the maximum value of the tau. Okay, then this again second observation, check that the variation of the tau above that rectangular beam will given the parabolic curve. Parabolic curve. Why parabolic curve? Again we have seen in the second unit. There is a, if you have checked the degree of that, you will get the second degree curve. Second degree curve. Alright. Equation is a second degree equation. That's why we can say we will get the variation of tau. Variation of tau is parabolic. Parabolic. Because why? What? Because in equation we get the second degree equation. Okay. What is the third observation? Check that where y is equal to d by 2. Y is your variable. This distance will vary. If you have considered here, then again you will get the y is here. Right? Y is your variable. If you are putting where y is equal to d by 2, y is equal to d by 2. This is the third observation. If you are putting the y is equal to d by 2, means here you will get the d square by 4 again. You will get the 0. Means tau you will get the 0. If you are putting the up distance d by 2, y is equal to, then tau is 0. Tau is 0. Reverse of that. Next, where y is 0. Where y is 0, then what is the value of tau? If y is 0, then you will get the tau is maximum. Tau is maximum. Tau is maximum. If you are putting the y is equal to 0, this where is you will get the maximum value for the shear stress at the centroid, at the neutral axis. At the neutral axis, that portion you will get the maximum value for the shear stress. Then similar way we want to calculate the value for the shear stress at the top and bottom. Top and bottom we have calculated at the neutral axis, right? And what is the value of top and bottom? Next is the shear stress at top and bottom. Then what is the value of y? If we have considered the top, then we know that from the neutral axis d by 2, and bottom again we will get the same d by 2. Means we will put here y is equal to what? D by 2. Y is equal to d by 2. Then at the top, tau top, you will get the 0. Also tau bottom, you will get the 0. Means at the shear stress at this point, we will get the 0. Top and bottom, this shear stress value, you will get the 0. Okay. Then similar way, shear stress at the neutral axis. Shear stress at neutral axis. What is the value of that y? At the neutral axis, this y is a 0. Y is a 0. Then check that you will get y is equal to 0. Then you have to put the value y is equal to 0. Tau suffix na. Tau at the neutral axis, y is equal to 0. Then you will get the 2 by 3. Here is a 3 by 2 is there, right? 3 by 2 into s as it is, and this d square and this d cube. D square is get cancelled. You will get only bd. Tau is equal to tau na. You will get the new relation. Tau na is equal to 3 by 2 into s into bd. And what is the relation between the tau max and tau average? The next one I will write here. Relation between the relation between tau max and tau average. So what is the tau average again? Relation between tau max and tau average. Check that here. S divided by BD means shear force divided by area, force upon area. This value is a tau average, and tau NA is equal to, you can write T by 2 tau average. Where is the tau? Where this value tau average? Tau average is equal to what? Tau average is equal to S divided by BD. Okay, force upon shear force upon area, shear area. Okay. Okay, this formula you have to remember. Otherwise, you can remember the only one formula. Tau is equal to S into A into Y bar divided by BI. With the help of that, you can calculate this value. You can calculate this value. All of you getting? Yes, clear? Very good. Then we'll see the some numericals. Okay. In this only you have to remember this formula. Tau is equal to S into A Y bar divided by BI. Okay. You have to consider the any area from that portion given section. Okay. Today we'll stop here.